Okay, if you've been following along, you'll see that I've been building a radio in module form. In other words, I can make a module for an RF front-end amp, a mixer, and I can swap the module out and make an improved module and swap it in. Now this is my automatic volume control module, or AGC, automatic gain, or automatic volume, whatever you want to call it. And I saw this article up on the internet, a simple adaptable AGC circuit for the simple high frequency communication receiver. And he shows the receiver he's got it in, but he also has the schematic with the parts. All right, and the guy's call is WA3TFS, James Forkin. Okay, and I told you in the last video about Penfold, and Penfold has a book that's in PDF form on the internet, and you can build a nice shortwave radio from scratch using his manual and my idea of using the toroid coils. You're going to have to improvise. A lot of things are not available anymore, but this circuit is very simple. You come in through capacitors with the signal, and right now it's working. I can reduce the signal, increase the signal. The signal from the top of the volume control. Remember, your AVC or automatic gain control signal is at the top of the volume control. That's so when you turn the volume of the radio all the way off, the circuit still sees the full amount of signal, and this circuit goes to your S meter. It also has a choice between minus going AVC signal or positive going AVC signal. But anyway, you come in off your signal source, which will be the top of the volume control. It goes through two capacitors, through a resistor, down to a transistor, and it gets amplified. That amplified AC signal goes through two diodes and a capacitor, becomes DC. It biases two different transistors. One is for the S meter, and one is for getting the minus or positive AVC signal. AVC or AGC. But I want to show you now. My circuit boards are always this size because this is the size that fits in an Altoid can. And if I want, I can place this circuit in an Altoid can and have it be shielded. And that was the original design idea. And then I started making changes. I started putting more parts on this on the perf board, and it's working out okay. Now my circuit all works. I really don't need an AVC or AGC control circuit, but I never really built one. In circuits that I have built, it was in part of the schematic, and I just added. So I wanted to become more familiar with the automatic gain, and the best place to have it control is the front end amplifier of the radio. Once you try controlling the signal when it's down in the IF strip, it's too late. It worked with a cheap radio, but I'm not building a cheap design. I'm trying to build the best design that I can build based on tube stuff using transistors. And there's many ways I could have just bought my way out of this. And I don't have a $40,000 lab, and I don't sit there in the chair facing the camera showing my face, showing you a pristine radio. This is all recycled parts. Even this piece of perf board came cut the way it is for an Altoid. This has been recycled, and all it is it takes an AC signal from the top of the volume control, it amplifies it, it rectifies it, and then it passes it on to whether you want it to, when the signal increases, do you want to go positive, or when the signal increases, do you want it to go negative? And you use one of those two signals to go up to the front end of your radio to turn the amplifier down when the signal goes too high, or back up when the signal goes too low. Very simple stuff, but you don't build something like this in an hour. This is 2 or 3 days on and off, so many parts per day. And here's the schematic. it's a lot more parts than I really wanted to build with. And I had all the parts. I had all the exact parts in all my cans and bins and cans, bins, and trays and drawers. And I made quite a mess just to build this. Now this is finished, and I'm in final testing. I have my power supply over here, my old 50-year-old power supply that I built from scratch. My old Macronta meter. It's actually a Sears Macronta. And this frequency generator is from a school system, and it came with documentation saying that none of the people in the school could fix it. It didn't make any sense at all to them. This is an electronics school, and what they did was they broke a trace that went through the board. They didn't realize the circuit board was 3 layers: top, bottom, and through the middle. And when they unsoldered one of the transistors for the output, which the kids burn out a lot, one of the kids must have tugged too hard, and he took the trace up from the middle of the circuit board. All I had to do was, I found it right away. I ran a piece of wire, because there's no fixing that. Ran a piece of wire, and it's an HP. I got it kind of cheap because it wasn't working, and it's not my favorite piece of equipment. Let me just say it that way. It would be nice to have something with digital readout and that, but it's not. It's just old-fashioned. It's probably the fanciest, one of the fanciest analogs they made, but it was for a school system. But I just want to show you, I am plugging along, and I think tomorrow I'm going to put the air conditioner in. Right now I have the fan off in order to make the video, but it's been really hot. Today is actually cooler, but it's been running 90 degrees. I think 5-6 days in a row, and that gets to be warm on an old body. I think that's it. All right, that's it.